First of all, on behalf of the organization, I welcome you. Just you are presenting the paper.
Thank you.
Tell me something about your paper. What is the concept? What?
Yeah.
Because word are very catching, data driven, and it is very fan.
Yes, sir. Yeah.
So that layman should understand this thing.
Yeah. So basically, rainwater harvesting, everyone know what is rainwater harvesting. But what we actually do is we go to the site and select the area. So what my methodology talks is sitting at the system itself, how we can do everything on machine learning. So we are trying to take the suitable sites from the existing site and train our model and bring a suitability map, something like this. So that's the idea of my data driven. Data driven is nothing but we take the suitable solutions, suitable locations from the site, train the model, understand the model, what is the difference between suitable site and unsuitable site, and then I give a unlabeled data, which is a new site, and then I will ask to do a prediction for the suitability sites. So that's the idea of this paper. So this we have done the study in Odisha, which is having the catchment something like this, and these are all the locations you can see.
Which area of the Odisha?
It's in Raigada district. So you can see the green ones are the suitable locations and the red ones are the unsuitable. So these are the existing locations on the site. So now I'm using these data points and training the machine learning algorithm. So I have used 3 models. SVM, Super Vector Machine Model, Random Forest and KNN. They are 3 different machine learning algorithms and they are mainly used for classification. So here we want to classify between a suitable site and an unsuitable site. So coming to the data and methodology, as I already told, I am using a high geospatial data, which is the LiDAR DEM, which gives you an idea of elevation and slope, because our rainwater harvesting mainly comes through the slope and elevation. And next is I am doing a hydrological model to identify how much stream flow is available at that area. So highly stream flow locations could be setting up the rainwater harvesting structures. All of these we send into these machine learning algorithms, and we evaluate the like metrics like overall accuracy, kappa score, precision, recall, F1 score. So these are all the model metrics which tells you how your model is performing. So if you can see here, yeah.
Okay,
If you can see here, this is the suitability map which is given by SVM. So we can see that the green areas here are showing you the suitability and the yellow areas are showing you the unsuitability. So out of all the 3 models, if you can see, these structures are mostly constructed on streams. So we can see the RF model, Random Forest, is giving you a more suitability when compared to the other models, and this is the AHP, which is the analytical hierarchy process, which is the traditional methodology. People use the weighting. So depending upon your weights and my weights, the suitability map might differ. So what will happen is, if we take this traditional methodology and do, we might end up constructing a structure at a place and no water is getting collected. So in Rajasthan also we had few places where structures were constructed but water was not getting populated over there. So this is the reason we understood that we should bring some automatic methodology where the expert advice should come here, not in the suitability map. So that's the idea or motivation behind our work.
Okay,
Yeah.
general question.
Yes.
If this data is existing, is available.
Yeah, it's available.
Okay, is available. It is, you have not acquired the data. Is not in existing data. You are existing data developed in a machine, are comprised and generating the different models.
Yeah, different
where
models.
we can utilize it.
Yeah.
How far it is going to play the role in the groundwater level?
In ground.
Groundwater level.
So
because
this-
everybody is dependent on rural area groundwater.
Yeah,
Groundwater is very convenient and everything. How it is going to help groundwater level? This
so-
catchment area you have identified this. Unless we improve the groundwater level.
So this work is done on the surface harvesting structures. The same methodology can be adopted for the groundwater, like recharge structures also.
I agree.
Yeah.
These are surface.
Yeah.
Water is flowing mostly depend upon the rainwater.
Yeah.
Rainwater harvesting. Rainwater is it flow?
Yeah.
Whatever it can absorb, whatever the structure you can here accumulate. But what is the rest of the water? Where did it flow? Where it has gone?
Yeah, if
It must have to be absorbed the groundwater.
Yes,
Where?
sir.
Are you doing something like that?
We
So
have
otherwise,
not done.
how much water is retained with this concept? Okay, rainwater is going on. Okay, you have created a structure, small structure, so that it didn't accumulate. But it was the ancient concept
Yeah,
like that.
yeah.
So okay, what about the rest of the water? It is waste.
that percolates into the ground. So there we can
When
construct.
if there is a hard rock, how it can percolate the ground?
So there we will not propose the recharge structures where percolation is not
Percolation
happening.
is not
So we will bring some more additional criteria like what is the percolation rate,
Okay.
what is the
Now I come to these
Yeah.
are the paper you have developed the new concept with
Yeah.
existing data. Who are the buyers? Intakes. Whatever the study you are doing, that you are testing. Who are the buyers? Who can take this?
so the
Okay, you come and just okay, you tested. Okay, who are the
So the Ministry of Jal Shakti and other water conservation people who are constructing these structures are now in more number. According to the government initiative, each state should
so
have.
you want to say that the government is the client?
Yeah, we
Government is a client.
Yeah, so because we have a project sanctioned to us with IIT Kanpur, Department of Science and Technology, where we are proposing a model.
This
So
is not
that
going to be very commercialized.
yeah, so we
You have to
yeah
change the thought process. Something how to integrate. Where in the big cities,
yeah.
rainwater harvesting is should be must.
So-
Now government is putting okay, it's to be accumulated underground.
Yeah.
Unless it is to be stored underground, surface is very difficult. And in a village area, people are dependent on the well, still well, a groundwater level, hand pump. So only that level is to be increased. If your data is integrated that in this way,
Yeah.
how you can modify with to increase the enhance the groundwater level. Then
The
it will be very
same,
useful.
the same method we will employ in groundwater, and we will consider different parameters which influence groundwater.
That is,
And
I do
then
not
we
know.
will.
I do not know what is the correct about science says. If you drill a borehole here,
Hmm.
rest of the water should go down. Somewhere must be.
Yeah.
So whatever
it's a
the
combination.
It's a combination.
Yeah, yeah.
So you also integrated. Okay, whatever the water flow
Yeah.
overflow is there, we should propose a proper place to borehole.
Okay.
So all the water
All the
will
water
go
will
there.
go there. Yeah, yeah. Got
That
it.
can be.
Sure,
So
we
this
will
is
think
you
about
just
that.
think of that way.
Yeah, yeah, sure. So thank you so
Thank you
much.
very much. Thank you.
Yeah.